Hello everyone, this is Mohammed Usman again with the ICP10, that is reinforcement learning. So today I'm going to talk about the DQN learning, which is and the problem and the goal of this ICP is to balance the black card and the pole, which is above the black card. So and the black card will move right and left in order to balance the pole. So let's dive into the code and let's talk about this. So the first thing is environment. So I'm importing the gem. So gem is the library which have these modules like the card pool and the taxi and so many things are there. So we are just using card pool example here. So this is the environment variable. I'm creating this, and here I'm just resetting the my environment state. Then there is an action. I'm just using the action space and storing this interaction. And here I'm just printing the state space, initial state, action space, and random action. So here you can see that the state space, we have the four states, which will be discussed later. And we have this is our initial state. And the action space is 2. You can see that 2. So either it goes left or either it go right. So these are my actions. You can see that if 0 mean push card to the left and 1 mean push card to the right, and the corresponding number is 0 and 1. And the state, which is denoted by S, so is an array of 4 real values. So the card position minimum value is minus 4.8 and maximum value is 4.8, and the card velocity is infinite, and pole angle is 24 degree in negative, and for positive is 24 degrees same. And the pole velocity, it's also infinite, minimum and maximum pole. So the reward thing, what is the reward thing here? So if the card move every step, it will get +1 reward. And for example, either it make the I mean either it change any step here. For example, if it go left or if it go right, so this is a one step, so it will get 1 + 1 reward. And this is what we need to do, what we want card to do, to go right and left in order to balance the pole above it. So this is the reward thing. Let's go for the DQN modeling. So this is the IA simple. It is to predict the Q value for the entire state, for the sample state and Q value data. So we need to predict the Q value. So we are using the here model, deep learning model, where X is the state, which is our input, and output is Y, which is our Q value, which is our also called target value. So here I'm just using TensorFlow Keras. I'm importing sequential and dense layer and number state. So what is the number state? The number state is observation space. So what is our observation space? This is our observation. This is our observation space. We have 4. And what is the number of action? We have the number of action, this either is 0, either is 1. So we need to predict this. So we are using 3-layer model. So in input dimension, we are just using number state, which is 4. As we discussed earlier, we have 4 state, and the activation is ReLU. And here I'm just using the same, and after that we are just compiling the model, and optimizer is Adam, which is very common. Okay, so agent, how the agent will collect the data. So here agent will collect the data while exploring the Q learning. So Q learning, what is that? It is the state, action, and reward. Then another state, then another action, then another reward. So and these Q learning will store in a memory like this. So this is my state 0, my action 0, and my reward 1. then my state 1, action 1, reward 2, then my state 2, action 2, reward 3, or reward 2, and so on. So it will store the its Q value like this. And what is the replay? At the end of one episode, the data stored in the memory are sampled in a random mini batch and then put into a deeper model and trained. So after every episode, like for example, this is the one episode here. So after every episode, the data will store in a batch and the model will be trained. So let's go to the training model. So in this while training the agent, so here we are just updating the Q value as the agent explores the environment over thousand of episodes. So here I'm using the thousand of episode. So let's jump into the code. So these are my hyperparameter epsilon gamma best size, and this is the number of episode, and this is the memory as we discussed earlier. So states, action, and reward we're going to store in the memory. So here uh, I'm describing the max length of the memory is 2000. Okay, so DQ and learning here. So I'm taking episode, which is the range in number episode which we describe here, but that is 1000. And I'm just resetting the environment is reset here, and done is equal to false. This is a bool function. So when it will true, it will get out from this while loop. So what's happening in while loop? So this condition check so whether it need to explore or whether it need to exploit. So if the random uniform is less than epsilon, which is 0.3, it will explore. And if it is not, then it will exploit. I mean, learn the values. So here you can see that it is appending each action in reward into the memory, and this is a replay function at the end of this. So it was just appending the Q. It is the it will store the state action reward. Then it will come here and it will store in the Q value, and it will predict like here as we discussed earlier here, and then put the deconverter and train after end of one episode. So after every episode, it comes here and it predict. Okay, so I have saved the model here, so I don't need to um, start the training again as it takes you can see that 1 hour 31 minutes. And okay, so the main challenge of this ICP is there was the error in env render, and the error is not resolving and in any way if you install the latest version of the Pikelet. So I came up with the solution after doing a couple of research. So you need to install the gym by virtual display and also this library. So here I will show you what's going in here. So this is the gym wrapper monitor, and here I'm just going to open the video which will be stored shortly. So here I'm just import the save model, and so I'm going to do, I'm just storing the card poll behavior in a form of video. So here, so you can see that I'm just giving the state to my model, which is save, and storing all the values. This is a show video function, which is here, show video function, and I'm storing all the behavior of the card in a form of video, and here that video is displaying. And here you can see that this card is just moving back and forth and it's not smooth. The reason is I just used 1000 episode here. If you go about like the 10,000 7,000 episode, so this card will be very smooth, but this 1000 episode takes one hour 31 1 minutes to train. So if you have more time, so you can increase this number of episode in order to make this card very smooth. This is all about this ICP10. And if you have any question, any comment, you can comment on the YouTube or you can reach me over the mail. Thank you so much.